this question admittedly is a little harder than what I would give you on a test, but I think it's a really good question to kind of see how you can manipulate these integrals and use U substitution. All right, so we said before, like when you have sine and cosine, they come in pairs, and so if we have a trig integral, we usually want to have sine and cosine as that pair, so sine of x and cosine x, so that our u and du work out. So again, like if u is equal to cosine x, then our du would be equal to negative sine x, and then we can make the substitution. Now, the problem though is we don't want to have, so first of all, let me rewrite this. So like this, again, we see the power, so we say, okay, that's sine x quantity squared. This is cosine x quantity to the third power dx. Now, when I rewrite that power, it's like, okay, do I choose u is equal to sine or do I choose u is equal to cosine? So just watch this for now. Let's kind of play around with it, see what happens when we pick a certain u. So let's say I pick u is equal to sine x. Then my du would be equal to cosine x dx. Now, the problem is that I have like a u, so I could replace this u as u squared, but then like this cosine x cubed, like how am I going to write that as my du? And so there is where we can split apart this cosine x to the third power. So we can say, okay, for our du, we only want to have a cosine x dx. So if we take one of the cosine x's out of here, that's going to leave us with two cosine x's left over. So this cosine x cubed would be cosine squared x times cosine x, and we're breaking this apart because we're really kind of a fan of the fact that we have this cosine x dx because that is equal to our du. So if we split apart the cosine cubed, that's going to give us that cosine x dx is our du, and then cosine squared x, and then u squared. Okay? Now, the problem still amounts to the fact that you have a u, but you don't have that x replaced with u. So here is where we try to play around with this, and we say, okay, well, my cosine squared, by the trig identity, sine squared x plus cosine squared x is equal to 1. I can convert that and say that cosine squared x is 1 minus sine squared x. Now, you really got to ask yourself, like, how is that even helpful? Well, remember that the goal is to get everything in terms of u. So what we can do is we can say, okay, u is equal to sine x. So this sine x squared would be the same as u squared because u is equal to sine x. And then we'd have 1 minus u squared as our cosine squared x. So using the hint that they give us, the trig identity, and the fact that u is equal to sine x, again, if u is equal to sine x, that means u squared, manipulating that, we would get sine squared x. So that allows us to take this cosine squared x and say that it's equal to 1 minus u squared. So if we take all of that information and we go down to our integral, we could write our integral as the integral of u squared, and then in for this cosine squared x, we could put the 1 minus u squared and then the du. Now, at that point, we still have parentheses. So it's like, okay, what should I do? Because I still have parentheses. So what I could do at that point is I could distribute the parentheses, because that's not too much of a job to just distribute the u squared to both terms. And so then I have the integral of u squared minus u to the fourth du. All right, so we can now integrate because we have everything in terms of u. So this was a lot of work to get it in terms of u, but once you get it in terms of u, you would integrate. So add 1 to the exponent, divide by the new exponent, same thing over here, and then plus c because we do not have our bounds. So after integrating, then we would switch back. So again, our u was equal to sine x. So when we switch back, we're going to replace this u with sine x to the third over 3 minus, and then this u is going to get replaced with sine x. So it's going to be sine x to the fifth over 5 plus c. And that is our final answer for the integral. And again, I just really want to emphasize, like, that question is harder than what you're going to have on your test, but it's a good example of what's to come in Calc 2 when you're going to manipulate all of these integrals and use a lot of your trig identities as well.